Thank you, Desmond. I'm very happy to be here at EMPEX because clearly this conference is about more than Elixir. Desmond said last night, it's always been about the music, the food, the experience. Can you believe this guy's moving to LA? Because I can believe it. And of course, Bobby. There's a lot more than Elixir here. But Elixir is a lot more than the language. Let's start with the language. I have here, oh, where is it? Oh no. Oh, where'd it go? Got it. Some Elixir, written on hotel stationery. And it looks like this. Now, this doesn't do anything in the computer, right? It's just the language, it's just syntax. It can communicate to people, but not as much as you think, in fact, because the language by itself, you think it's super specific because it's a programming language. You're like, just show me the code. I need to know what it does. And, but that depends on the specification of the language. It depends on the documentation. So without Elixir's very good and accessible documentation, this isn't much good. It also depends on you knowing what these modules do that I called, or having access to them, in which case it can communicate, but a little slower than I would like. There's another reason why this doesn't communicate as quickly as I think it does. That's a problem of complex systems in general. As soon as you get past a trivial program, then you have a complex system. And it's organized complexity. It's like systems come in like simple ones, basic mechanical ones where you can use cause and effect and the lever goes this way and I can see that happen. Or you can have like complicated ones like gas in a room, but each molecule only affects the molecules right next to it, never the ones across the room. So you can use like statistics, and it's still kind of counterintuitive, but we can model those and come up with some sort of least probabilistic causality. But organized complexity means that the parts affect the other parts in ways that are hard to predict. And those systems, even small ones, are subject to the principle of uphill analysis and downhill synthesis. And this is from the book Vehicles by Valentino Breitenberg. What it means is, you wouldn't expect it, but these systems are a lot easier to build, the synthesis is downhill, than they are to figure out when you come at them from outside and look at them. So as programmers, like mathematicians, we're creating worlds in our head. But then we get to make those worlds come alive in the computer, and we get to interact with them and figure them out and expand them and grow them. And that's really cool, but it turns out that building a world in your head is a lot easier than figuring out the world somebody else built based on the output. So our programs are a lot harder to understand coming at them. This is the curse of legacy code. You think the code is bad. No, this is inherently way harder than building from greenfield. I guess that's why I like legacy code. So that's the language itself doesn't give us enough information. The way you do figure out a complex system, because you can't just look at it and figure it out, the way you do is by experimenting with it. You poke it and see what it does. Does this do what I think it does? Oh, look at that. Because looking at one line of code and figuring out what that does and all the things it affects and why it has those effects and which stakeholders actually care about those effects, that's asking a lot. We need to be able to experiment with our systems in order to learn about them and figure them out. And so we go to the REPL. So we could run this piece of code in the REPL. There it is. Nope, almost. There it is. No, that's not gonna work. Oh no, oh no. Oh no. Right. There it is. Did it paste it? It didn't paste it. It's about to paste it. Here's that piece of code. Okay, there it goes. See? Now, would you have guessed that that's what it does? I mean, it's not very exciting, but it's not something you would guess just from reading that piece of code, partly because you haven't seen the Yo module. And then, so the REPL is super important because it's a really fast feedback loop. So Elixir is more than the language. I don't need to go into the runtime. Sasha covered that. But the REPL, for instance, gives us that interface to the runtime that gives us a really quick feedback loop, because humans are great at learning when the feedback is immediate, and we are crap at learning when it takes a long time. More than a week or two, forget it. This is why annual reviews are so useless. But the REPL gives us that immediate, quick as we can feedback loop. So that's useful for experimenting with small pieces of code. And then if I want this code to become more useful, I can go up to a script. And could somebody pop into the green room and grab my dinosaur, because I forgot it. It's on the table in there. The next stage, we need to get back to Keynote, don't we? After the REPL is in making this piece of code useful, is to put it in a script. So a script is a program. Thank you. I worked really hard on this in the last hour, can you tell? And it's a toy. A program I define, as opposed to software, as a piece of code that you can run repeatedly on your machine and it's useful to you. So it's like this clay dinosaur in the sense that I can play with this, and I know this represents a T-Rex, and I know that my favorite part are its wee little arms. But nobody else has to be able to figure it out or put it back together when its leg falls off. It doesn't have to run anywhere else. And this is trivial and it's fun, and now I have a thing that I can go over here and I can do this over and over. And I can type elixirify, and I can get my Empire Elixir. Okay, I have condensed those however many steps into one step. Now I do a lot of this more and more lately as I've come to think about software the way I do now and programs. So I mean, that one's probably not useful to me. But I've got a little bash alias that if I type B London, then it goes to the London project and it changes the title of the tab to London so I can find it again. Yes, that's two operations condensed into one. But anything we condense multiple steps into one creates a new primitive. It's a new thing that we don't have to think about multiple things anymore, and so we can fit more in our head. It expands our logical sphere. So these little dinosaurs can turn out to be pretty useful, because now I have a single dinosaur concept here. Okay, having done that, the script, however, as soon as I want this to be useful for more than right now, then I want tests. So Elixir has provided us with the REPL, with the Elixir and the IES files, and it provides us with tests. Tests are built into Mix and built into the language. You don't have to add a framework like you do in Java or the older languages. So a lot of what Elixir is, besides the language, is a modern programming system. Somewhere back in the 80s or around there, the academic literature shifts from talking about programming systems like Lisp, Smalltalk as a programming system, like entire environments, to talking about programming languages. And that turned out to be really interesting academically, to study just the languages and their syntax and what they can express and what they compile to and what their performance is. But that's not enough for us, because that's here. So the programming system, that is stuff like tests, because we have to know how our programs work, or we have to know how we know that our programs work, which is a lot harder than just making them work. This works, but I can't prove it to you repeatedly. And then after tests, we move on, and as we want to make our program into something more useful, we start bringing in external code. And there's a lot of system behind the dependencies that we bring into Elixir that wasn't as robust back in the Erlang only days. So certainly there's Hex as a package manager. That is making it easy for people to share their work, to upload packages. And there's more to it, because it makes it easy for people to upload their work well with stuff like Hex docs. If you make it easy for people to do the right thing, they're totally going to do it well. But if it's do it wrong or not do it at all, because there's deadlines and there's time boxes, and we're never going to get it done when it's hard, We really change behavior when we make something easy. And that affects everyone because then everyone benefits from the docs. So it's not enough to have libraries available. You also have to be able to find them. You have to be able to know which ones are good, and that gets into the whole community. There's a lot to making Elixir useful. A mix and mixed depths. So I was looking at Rebar, and Rebar is we don't even mess with trying to figure out what version you want. We're just taking the one at the top of the tree because if we tried to impose some sort of numbering scheme, we'd have to change how all this Erlang stuff is implemented. And Mix says, no, I'm going to do dependent semantic versioning. So there's a lot of modernity that Elixir has added to the ecosystem, to that beautiful Beam runtime. And at this point, you might have a program that's this is a plastic toy dinosaur level. All right, but anymore, the standards of software are enough that we can't write them ourselves. And we need a team, and we need internal dependencies. Avdi Grimm says that his best metaphor for software development, because it's not architecture, sorry, it's not engineering, it's really not manufacturing. He's like, but the dream architect's in Inception. It's totally corny. But to create software, we first have to create this world in our head and then put it in the computer and see whether it works. And these tests and the compiler and the REPL are all telling us whether our world has inconsistencies and should implode, like Dr. Chang said this morning. But to work as a team, we have to create a shared world together. So the dream architects, they have to come up with this world that's sufficiently self-consistent, even though it's not subject to all our physical laws. It's self-consistent enough for the entire team to be able to hold it in their heads and the machine to be able to work. So that's what we're doing when we're working with a team. I think Elixir has some particularly cool things here because I was looking at umbrella projects, and first I was like, oh no, it's the monorepo. I hate the monorepo. I do hate the monorepo. However, my biggest problem with the monorepo is that it's an illusion. So in Java or any other runtime, if you have any service-oriented architecture, if you have a giant repo and you've got all your services in it and you're like, look, this is consistent, and you think you have a picture of consistent code, but deployment has nothing to do with that because all the different bits are deployed at different times, then the monorepo is just deceiving you. You don't really have that consistency, not in the real world. But if you're using Distillery and Erlang releases, you can actually say, no, this commit right here, this describes the apps that should go to production together, all into the Beam, and it actually loads them all. And that's really cool. So there's another thing about the Elixir programming system that makes it special. And then moving on, beyond combining our apps with others, we then need to ask, does it work together? And continuous integration, we're all using our different tools for that, and Elixir has integrations with those. There's so many pieces to this. And then you get to deployment, and deployment seems to be a pretty personal thing. I haven't seen a generic deployment system get wide adoption. It seems to be pretty specific to everybody in all of their environment. But Elixir, on the website, I counted them, has 23 different installer integrations so that you can get it into whatever deployment system and environment you want to run it in. That is some friendly interop with the rest of the world. Because our programming systems, it's not like Smalltalk, which was all isolated, and Smalltalk runs in Smalltalk on Smalltalk. That's not how we run programs anymore. Yes, Elixir is going to execute on the Beam, but it might be the Beam in Docker, on Kubernetes, on EC2, on whatever mystery lies behind that. So we have to be friendly and fit in with the world. It gets bigger and bigger, and I think the difference between this program, here's the program, and actual software that is useful to hundreds of millions of people on hundreds of millions of different computers and devices, it's more than orders of magnitudes. It's thousands or millions of times harder and more expensive. After deployment, finally we get our software out into the world. And this is where we can finally learn whether it's useful. Because this is easy. This is useful to us, and it only has to be useful to us. We know whether it's useful immediately. I can tell you that my little B script, oh my gosh, that's so useful. I use it 10 times a day. Even though it's tiny, I use it a zillion times. that little Elixir 5 script, I'll probably never run again. But it's much harder to know whether our software is useful to users. So this is why I like Elixir, I like dynamic languages that are not super focused on correctness. It's not about bend your mind to the machine or to the category theory or whatever convoluted type system we've come up with to make it possible to make incorrect code inexpressible. Elixir just lets you express what you can. It's going to give you some clues along the way of whether it might work. But in the end, knowing what's correct is easier than knowing what's useful. And you can be as correct as you want, and if it's not useful, it's not going anywhere. Software is about changing the world of our users. We're creating the world in our heads, we put it in the computer, and then it changes other people's world. I mean, we create our own physics. When I pushed that combination of buttons before I wrote that script, they didn't do what they now do. A ride-sharing app totally changes the way I interact with St. Louis, because now there's a way to go out and drink without driving home drunk. Public transit stops at 11, Uber does not. I wish we had Lyft. But it changes the way the world works, and suddenly something that was a problem for me is no longer a problem, and now I don't even have to think about how I can get home. I can just think about, well, where do I want to go? Anywhere in the city is open to me now. My world is bigger because something that used to be hard is now easy. And that's what we're doing. And in this whole process, for us, it's crucial that this process is fun for us. And that's why we like Elixir, the experience, and EMPEX, the experience. Because we want to get from the dinosaur to something much more elaborate. This is a dinosaur playground, for instance, that's installed in a park near my house. And this is probably tens or $100,000, I don't know. And this is not too. So it's several orders of magnitude more expensive, but immensely more useful. This actually changes the powers that my daughter Linda there has to play. She can play in ways she couldn't before. And look, it's got like UX, and it's very pleasing to look at, and it's got discoverability. There's clear ways to play with, and it's also flexible. She can do whatever. It's got safety, because the squishy ground, if she falls, she won't die. Safety is not about preventing failure. It's about preventing unacceptable losses. And I don't mind if she scrapes herself as long as she doesn't permanently injure herself. We're good. So that's like supervision trees. This is the level of difference that we're going for, and it takes all of the Elixir ecosystem and a lot more to get there. So here's our users interacting with our software system, and we also interact with our software system because this is your team. This is the socio-technical system that you work in. There's people and there's our code, and we affect the code, and Lord knows the code affects our quality of life. And also our tools impact us. And it's a lot more than Elixir. We can get our Elixir specific stuff, but then we also need version control and centralized version control and integration and issue tracking. Coordination is totally one of the hardest problems, coordination between people, and deployment and artifacts and blah, blah. And unfortunately, we can't get away from the JavaScript tools. But we have control over this. We have more control over our system than just choosing the language and ecosystem and runtime that we're going to work in. Because we can build on top of this. Our superpower as developers, as creators of little worlds, we can create our own world the way we want it. So here's a plug for local automation. Automation is a little bit bigger than this dinosaur, which only works for me. It's maybe the plastic toy dinosaur, because local automation, like local to your team. This is a serious sweet spot, I think, that is underutilized in development teams because it's cheap compared to the playground. It's changeable. Automation for users is sometimes dangerous. The playground is nice and flexible, but a lot of the times we wind up creating exactly one way for people to get a ride when they need some flexibility, like I need to move my pickup point. automation can be dangerous in that it can ossify processes if you're not careful, but not in our teams because it's ours. And hopefully we're either the authors of it or close enough to it that we can be on that downhill synthesis slope and understand how the system works. And it changes behavior. So if you are thinking, well, I deploy about once a week and it takes me 3 hours. So if I spend a whole week automating my deploy process, it's going to take me a long time for that to be worth it. You're wrong. Because automation is a lot more than the number of times you currently do it times the time you spend. Because if instead of being 8 steps in 3 hours, deployment is 1 step and half an hour of making sure it didn't go wrong. And rollback is also 1 step, so you're not afraid. And you're never going to screw it up again because it's just 1 step, and you're not going to forget halfway through because it's just 1 step. You're going to deploy 4 or 5 times a week. And think how much time you're saving there. You got your time back very quickly. Oh, and then the rest of your team is doing that too. There's way more to automation than just the time you know you'll save, because it changes behavior. If you make something easy, people are gonna do it. So make the right things easy. We can consciously choose to change the physics of our development team to make the things we want people to do fast. I work at Atomist now, which is exciting because we work on development automation. Our goal is to make even more of this local automation easier, because I mean, I can write a bash script and stuff, that's cool, but I actually need to coordinate between GitHub and Travis and Kubernetes, and then I need all that information in one place. So we're trying to make that easier so that you can write programs that run on our infrastructure. And the result is, like, for instance, I can, in one Slack command, spin up a new project, not just on my local file system, but in GitHub. It creates a repo, and it's based on whatever my org's latest standards are, which I can continually update, and then the new projects will be new, and then there's more to it than that. But and I also get a Slack channel, and the GitHub repo and the Slack channel talk to each other. And then in another single step, single Slack command, I can hook up Travis CI and Kubernetes deployment, and that wires in together with Slack and the graph database that stores the relationships between these things. And so instead of a bunch of unrelated messages in Slack, I get one little mini dashboard here that's like, for this push, and then it'll notify me about the push, and then when the build starts on Travis, it'll put this up here, but it'll be yellow, and when it completes, it'll be green, and then, oh look, we got a tag, and there's buttons here. If the build fails, you can click restart, kind of thing, and then these buttons give you like little local actions to take, and there's finally deployed. You know, it seems like not a big thing because you can already get all these notifications into Slack, but they're all separated. But it's taking several things and making it one. There's several sites in here that I don't need to go to because I have buttons. It's small, but it's slick, and it really like improves my day. So as developers, we have the power to craft our world like this. And the more we can put into the logical sphere, or I would argue the automated sphere of single primitive operations, then the more things we can think about. If deploy goes from 8 steps to 1, that is 7 more things that I get to think about while I'm thinking about deployment. Another thing that we do at Atomist, and I love this part, and it's open source, is we have some code to modify code. So, I was listening to Woody Zuhl earlier this week talking about no estimates. And somebody asked later that night in the bar, somebody was like, what makes us so special? Every other industry can like predict their work. Construction predicts their work. Auto repair predicts their work. Why can't we be expected to say how long something is going to take? And I'm like, because we never do the same thing twice. We are creating something new every time we do it. You know, we've never repaired this muffler before because the first time we repair it, well, it stays repaired or it repairs itself again. Okay, that didn't work. We're not doing the same thing over and over again. We're not doing engineering or architecture because we're creating and modifying a complex system that we cannot fully understand all at once. Everything we do is an experiment, and we can check our work to see whether it's right. But It's not predictable. And if it is predictable, automate it. So somebody was like, well, certain categories of tasks we've done several times before, so I should be able to say 5 days, 5 days. I'm sorry, if it's that predictable, write code to do that task for you. If you have a predictable estimate that you make, it should be an hour. It'll take that long for the CI and deploy to finish. And we are working on code that modifies code, and what I like about that is it's an alternative to metaprogramming with macros that doesn't obfuscate or add any indirection to the code. Nobody even has to know. This is super useful with Elm. I love the explicitness of Elm, but it is 5 changes minimum to add an input field. But I can make that one step. I can make that a primitive, and then my little program makes a pull request for me on a branch, and then I can continue working on that branch to make the input field do something. We can automate our work in a way that maximizes the language for understandability to make that uphill analysis a little less uphill, because you don't have to dig through to figure out what that macro does, but you also didn't have to type it. So I get really excited about that. All right, there's one more reason that we should do local automation. Actually, this is kind of the negation of an excuse. Because, yeah, I would love to automate my work, but that's not my job. My job is to build features for users. Here's a word that I learned from the Journal of Organizational Psychology: generativity. This was in an article about executive teams, and I've come to realize that executive teams and developer teams have a lot in common because we're systems builders. They're building a business organization, a human, mostly human, some technical organization, and we're building a mostly technical system. But we're all systems builders. Generativity is defined here as the difference between your team's output with you and your team's output without you. That's very different from your individual productivity. Because we used to talk about 10x developers. I'm sorry. If you are a 10x developer compared to someone else on your team, you are doing it wrong. You're probably hoarding information that they need. You probably wrote the thing, and you're on the downhill synthesis side, and they're struggling up the uphill analysis side, and by the time they understand anything, you've made it more complicated. Or you just need to help them understand the system, and a 10x developer is like a smell. A 10x team, on the other hand, is something else. And I have seen people who build 10x, or maybe 5x or 3x, whatever, who build teams that are drastically more productive, more able to create, and create safely than other teams. So when you are spending your time on local automation that makes your team's operations safer or easier or faster, then you're being generative while you're not being productive. And if you look at your job this way and your impact a lot wider, your effect on the whole system of the team, then as teams we can grow. And as a person also, you have a lot more options and flexibility. There's a lot more ways to grow a team than to increase your personal output compared to somebody else. So here we are, working in our Sociotechnical System, that is us and our code. And Agile, real Agile, not Scrum, was beautiful because it finally put the focus on the interactions between the people, and then XP put some focus on the code's effect on us. Like, pairing helps us create that shared world, and TDD helps the code give us feedback a lot faster so we can do more rapid experiments. There's something else we can get out of this, though. Something else that's unique about the software industry compared to anywhere else, because for the first time in humans, we are able to build a complex system and experiment with it on a time scale of days or weeks. We can make a change, see it in production, and find out whether it helped or brought everything down. And this is new. Software is a medium of complex systems that we can manipulate on human learnable timescales. We're surrounded by incredibly complex systems. We are complex systems. Biology is all super complex, and the environment, and our organizations, and the economy. All of these are complex systems, and all of them are incredibly slow to change. We can change them, and we work on that, but it's slow. The executive team is making changes on the scale of, it's going to be a year, at least, before they can see their results. We can see results tomorrow. And that means we can learn about complex systems. We learn how to modify complex systems. And this is why I think the software industry is unique and, in fact, has something to teach the rest of the world, which is all operating in complex systems that they've never been able to change before at that time scale. So, like, as an example, here's a database, and pretend this is like a replicated, sharded, distributed database, and there's some application, and it's also whatever. One of these database servers goes down, and that particular shard gets slow. If the app is old style and not very smart and is only in its own little world, it says, oh, it didn't respond fast enough. Retry. And pretty soon, all the replicas of that shard are down because the load has increased and they couldn't handle it. And this app was just doing its job, right? But this app was in its own little world and wasn't thinking about the system as a whole. When, as application developers, we start thinking about the system as a whole, then we say, ooh, that database looks like it's having a bad day. Maybe I better go easy on it. We do this as people with our teammates. It's a lot harder to do it with someone else, say, in another car. But when we widen our perspective like that, then the app says, okay, well, I'll do exponential back off, and I'll switch some of my calls over to a fallback, and I'll just go easy on the database for a little while until it recovers and starts working again, and then we're back to normal. That is a complex system that's working because each piece of it took a broader perspective. We do that with people, DevOps. So if the developers are like, we're trying to push we're writing the features as fast as we can, and we want to push them out, but that stupid operations team is always in the way. And the operations team is like, our job is to keep the system stable, and they keep bringing it down, so we need to go slower. We need to do fewer releases. And the developers are like, then the releases will have more crappy features in them. And so the developers think the ops are dorks, and the ops think the developers are incompetent because they're not taking the perspective that they both influence each other's work. And when we widen it, and this is the point of DevOps, it's systems thinking. It's our features affect the operations, and our operations affect the rollout of features. And when we take that broader perspective and work together to achieve our joint objective of safe changes as fast as we can make them, then we get something else. It doesn't actually matter whether they're on the same team or the same person. What matters is that they're working together to achieve the common goal instead of opposed to each other. This is coming from The Fifth Discipline by Peter Senge, which is a book about organizations. It's about how to build a learning organization. It was written in the 90s, and it's obviously brilliant. And why didn't it catch on? I think it's catching on now because we have lessons we've learned from software. Software is finally giving us the feedback loop that we need to figure out systems thinking. So Peter Senge, we're learning it from this and we're applying it to this, and Peter Senge says that when you just take your own perspective, the app by itself or the developers by themselves, and you're in linear thinking, you think that cause and effect is a one-way thing. You think the interesting stuff doesn't happen in spirals. You think like if A then B applies to the real world. No, nothing is logical. Nothing interesting is logical in the real world. So the developers, like any person who is thinking linearly, if my situation is bad, then it is because some other person or group of people either negligently or willfully made it bad. They're out to get me. It's their fault. It's that other stupid driver who didn't go at the green light. You couldn't see the turtle crossing the road. When we think linearly, then we get to blame and we get to victimhood. When we think in systems, when we broaden the perspective of, crap, my situation has worsened. Maybe theirs has too. Maybe we can step back and change the system as a whole. if we can learn systems thinking and take that to the rest of the world, how could this help our larger socio-political climate? If we can lose oh, I'm sad, it must be somebody's fault. No, we're in this together. Works in DevOps, and I hope we can bring it to the world too. And finally, while we're talking about us as creators, Cameron said last night, the jobs ain't nothing but work. This is true. But when you look at programming, at software, as this magical medium of creation, the worlds we build in our head, made alive in the computer, and sent out into the world to change other people's worlds, why wouldn't we do this on weekends? This is awesome. This is like, you play music on weekends, you do woodworking, why wouldn't you code? It can be art. And when we do that, and when we look at it like that, well, yeah, we're not like workaholics. And also, when you do that, use the language you darn well enjoy using. Don't worry about, can I get a job in it? That'll come. What did Eugenia say? That the best maths started out just for fun and became useful later. So yeah, spend your weekends coding and enjoy yourself. You'll learn the work-related stuff at work. You're fine. You're fine. As software developers, we have a lot of power. We have unique power in this world currently. We can create. We can use that for our own fun. We can create our own team's world. We can learn about how complex systems work. We can learn that wider perspective and then apply that to life. And we create our users' world. So I hope we're building playgrounds that make people's worlds fun without restricting them. I know this conference has made my world bigger, and software makes my world bigger. And yeah, I hope we can keep creating and keep learning from it. Go forth and elixirify.